In part B of this question, we're asked for what is the specific volume in meters cubed per kilogram at 28 megapascals and 200 degrees C. So again, if we want to find out what is this state, we have to convert to what we have available on our table. So if we look at table B7 in Appendix B on page 650 in Felder, again, all of our pressures in bar. So to convert 28 megapascals to bar, this is equal to 280 bar, which is a pretty high pressure. Now, if we look at the column for 200 degrees C, when we go all the way down, we can find data at 250 and at 300 bar. So since we're looking for a specific volume, at 250, we find that it's 0.00113 meters cubed per kilogram. And we also find that it's 0.00113 meters cubed per kilogram at 300 bar. So if you remember from before, this is actually a pretty low specific volume. And if we look at our pressure on the table on the far left, we can see that our critical pressure is 221 bar and 374 degrees C. But whereas for a temperature that's less than the critical temperature, but for a pressure that's greater than the critical pressure. So if you look at our isobars, they kind of go like this on a TV diagram. The isobar for the critical point following like this. So we can see pretty closely that 280 is never going to touch the 200 degree line of equal temperature up here. So it must clearly intersect it down here, which agrees with what we found for our two specific volumes at 250 and 300 bar. So if we look actually at the phase diagram, it's going to be about right here, which tells us it's in the subcooled liquid region, which makes sense. It's above the critical point, but so it doesn't necessarily have that phase that we can say, but it is a low specific volume fluid. And now, as far as finding the exact value, we don't even need to interpolate. I mean, we could, but there'd be no point because we can see that there's no change between these two here. So the pressure is so high that at that high of pressure, there's virtually no difference. The lines are so close together around that point that it doesn't really change much. And so we can say that the specific volume here is equal to 0.00113 meters cubed per kilogram. And that's at 28 megapascals and 200 degrees C. That's for part B.